Welcome students, I am Adeline Levinshaw, lecturer of Emmanuel Arasar College of Pharmacy. Today topic we see about the flame photometry. First we see the introduction. Flame photometry is also known as flame photometry or flame emission spectroscopy. These are the other names of flame photometry. It is one of the emission spectroscopy which is used to detect the metals belongs to group 1A and group 2A group of periodic table. For example, we detect sodium, potassium, lithium, magnesium are detected. In this flame photometry is based on the measurement of intensity of the light emitted when a metal is introduced into the flame. One metal is introduced into the flame, we will measurement the intensity of the light. Principle: when a solution of metallic salt is sprayed as fine droplets into the flame, due to the heat of flame, solvent in droplets vaporize, leaving a fine residue of salt. The salt is converted into gaseous state, and this gaseous state is next be converted into the neutral atoms. That is called the atomizations. Due to the thermal energy of the flame, the atoms get excited. That excited atoms are unstable, so quickly return to the excited state to ground state. This process we excited atoms emit radiation of specific wavelength. This wavelength of radiation emitted is specific for every elements. Liquid state is changed into the solid state, that is called vaporization, and the solid state is again changed into the gaseous state. In between the process we have the transformation, then the gaseous state change into the free neutral atom. In these two process we do the atomizations, and the free neutral atoms are excitations will happen to the excited state, excited state, and the excited state of the atoms, then we excited to ground state, and in between the radiations or emit radiations or go to the detector and read out the measurements. This is the picture of the flame photometry. Next we see the instrumentations of flame photometry. First we see the structural picture. First have the burner flame and lens, filter, photo detector, amplifier and recorder, etc. Nebulizer, etc. The major components is sample delivery system, second one source, third one monochromator, fourth one detector, and fifth one readout device. These are the systematic representations of the flame photometry. First one, sample delivery system. There are three components are introduced in this liquid sample. First one, the nebulizer, second one is aerosol modifier, third one is flame or atomizer. And the flame, it is also known as the atomizer. In first one, nebulizer, it breaks up the liquid into small droplets. It helps to break the small droplets. Aerosol modifier, it helpful for the remove larger droplets from the stream and allow only smaller droplets than the certain size to pass the sample into the other system. Third one is the flame or atomizer. It converts the analyte into free atom. This is the sampling delivery system. In the source, we use the burners or we used to spray the sample solution into fine droplets. The several burners are we use in the flame photometry. There are pre-mixed Becker, total consumption, shield burner, nitrous oxide, acetylene flames. These are used in the flame photometry burners. This is the structure of the flame. In structure of the flame, there are major zones are have. First one is the preheating zone, second one primary reaction zone, it is also known as inner zone, third one international zone, fourth one secondary reaction zone. Preheating zone means In this combustion, mixture is heated to the ignition temperature by thermal condition from the primary reaction zone. Second one, primary reaction zone range thickness is 0.1 millimeter at pressure, atmospheric pressure. In this region is not used for the flame photometry. Third one, interconal zone. It considerable height. Maximum temperature is achieved the tip of the inner zone. This zone is used for the flame photometry, but not used for primary reaction zone is not used for flame photometry. Fourth one is secondary reaction zone. This process of band to stable by the surrounding area. These are the structures of flame and the zones. Next one, requirements of flame. In requirements, we need the proper temperature. Next, we need the remain constant temperature, and we need does not need any fluctuation during burning the burners. And next one, function of flame. What are the functions we need the flame? First function is to convert analyte into vapor state. The liquid sample is converted and the analyte into vapor state. Second one, decompose the analyte into atoms. Third one, emit radiant energy. These are the functions of flame. List of fuels and oxidants used. What are the fuels we used and oxidants are used? What are the fuels we used in the flame photometry? Town gas, propane, butane, acetylene, town gas, propane, butane, acetylene. Next, we use the oxidant temperature. This list we follow the burners flame. First, for examples of burners, Meckel burner we use. This is the primitive type of burner used in flame photometry. It is used in earlier stage we use the flame photometry this burner only. Bagger burner. How it works means works with the aid of natural gas and oxygen as fuel and oxidant. Nowadays not used. This burner is nowadays not used. But earlier days we use only this Bagger burner. Second one, total consumption burner. In this burner we use fuels or ethylene and H2. The burners use hydrogen along with oxygen in order to produce hot flame. In this burner we are generally aqueous main function is atomization and excitation process is done by the total consumption burner. In this type of burner, the liquid burner fuel and oxidants are introduced into burner through different inlets. The residue is further reduced to atoms follow the excitation. This is the picture of the total consumption burner. In this burner have flame base, fuel, oxidant, capillary tube, liquid, sample. Fuel and oxidants are first, this working process is fuel and oxidants are bound together to produce flame at the top. The liquid sample is drawn from the bottom. When this liquid sample reaches the base of the flame, it is expelled by the oxygen into droplets. The residue is further reduced to atom followed by the excitation process. This is the working conditions, and we see the total consumption burner merits and demerits, that is advantage and disadvantage. Advantage is entire consumption of sample. It consists small area. It is turbulent. Most type of flame used for the most type of flame. Demerits is very noisy and productions of non-uniform flame and turbulence is produced. These are the advantage and disadvantage of total consumption burner. Third one, premix of laminar flow burner. In this burner of sample, Fuel oxidants are thoroughly mixed before aspirations and reaching to flame. The gases move in non-turbulent factions, that is laminar flow. This is the picture of the laminar flow burner. Only small portion, that is 5% of sample in the form of small droplet reaches the flame and is easily decomposed. And in this burner, premise burner is also known as the laminar flow burner because of gases moves in laminar. Advantages of the laminar flow burner: uniform flame produce. First main advantage is uniform flame produce, but in the total consumption burner not produce the uniform flame. But this burner, premix burner or laminar flow burner produce the uniform flame produce noiseless, but that burner produce the noise, but this one is noiseless, non-turbulent and stable. Disadvantages are heavy loss of miss up to 95% of the loss will be produced in this burner. Second one, smaller number of atoms reaches the flames, so reduce the emission intensity and give incorrect result will be produced in this burner. These are the advantages and disadvantages. Next one, third one. First we see the sampling handling, next we saw source, burner, flames, etc. Third process of instrumentation is mirror. We choose the mirror in the flame photometry. Mirror play the important role in the flame photometry. Flame emit radiation in all direction and result in the loss of radiation. We use the concave mirror is used in the flame photometry. The radiation emitted by the flame is generally towards all the direction. Mirror is placed in the flame photometry behind the flame. If focus the radiation towards the entrance slit of the monochromator, a concave mirror is used as it is front face reflecting type. This is the picture of the mirror. This is the concave mirror. It helps in reflecting the radiation back to the entrance slit of the monochromator. Household mirrors are not used in flame photometry, but because why the household mirrors are not used in the flame photometry means they are made up of support material such as glass or quartz. So the household mirrors are not used in the flame photometry. Fourth one's instrumentation process is monochromators. Mirror after process is mirror mirror contain the two types of slits. Entrance, one slit having entrance and other slit having the assist region of the flame photometry. The entrance slit is placed in front of monochromator in front of once the entrance slit is present, but the entrance slit it helpful for the allow only the radiation emitted from the flame and mirror reflection to the end of the monochromator. Next one, second assist slit is placed after the monochromator. Its main uses is help allow only the selected wavelength. These are the two slits present in the monochromator before and after. Next one, monochromator. The monochromator is main device in the flame photometry. Is a device which converts a polychromatic beam into the monochromatic beam. There are two types of monochromator we use. One is prism monochromator, second one is grafting. Prism monochromator, the quartz it is made up of quartz and hence it is transparent in nature. It is most commonly used in the many instruments. Grafting, second one is grafting monochromator. It converts the polychromatic light into the monochromatic light more efficiently when compared to prism. Convert பண்ணும்போது more efficiently we we converts the polychromatic light into monochromatic light. The grating monochromate is made up of glass coated aluminum, but prism, the quartz is it is made up of quartz, but grafting is made up of glass coated aluminum. These are the two types of monochromator we use in the flame photometry. In these main uses of the monochromator, it converts the polychromatic light into the monochromatic light. Detectors. Detectors, we use the main uses of detectors in the instrumentation is convert the light energy into electrical signal. When light energy passes through the monochromator flame and passes through the monochromator, that light will convert it into the electrical signal which display on readout device. The emitter radiation falls on the detector which determines the intensity of radiation emitted by the sample. There are many types of detectors we use: photomultiplier tube, photoemissive cell, photovoltaic cells. These are the types of detectors we use in the flame photometry. But generally used detectors is photomultiplier detector because it produces electrical signal when the radiation falls on it. So we use the photomultiplier detectors are mostly used in the flame photometry. First one, photomultiplier tube. In this this is the picture of the photomultiplier tube. This is used in the flame photometry. It's the main detector we used in the flame photometry. The main construction means working means the radiation which is fall on the photocathode and release electron, and that release electron strikes the dianode, causes multiplicity of the electron in the ration of 10 raised to n. N means number of electrons present in this dianode. Here the light radiations can be converted into electrical signal. This is the working process of the photomultiplier tube. The surface of dianode is BeCu, CsCb or similar material. The photocathode surface is of alkali or alkali metal oxide. The consisting of evacuated tube which contain one photocathode and 9 to 16 electrodes known as diodes. This is the construction. I tell about the working in start of the photomultiplier tube. Once again I read it. The radiation striking the photosensitive cathode give rise to photoelectrodes by photoelectric effect. Diode D1 is held on at positive voltage with respect to the photocathode. The electron emitted by the cathode are attracted to the first diode D1 and accelerated in the field. Third point, each electron striking diode D1 thus give rise to 2 to 4 secondary electrons. These are attracted to diode D2 which is again positive with respect to diode D1. By the time this process has been repeated 9 times, this said electrode is finally collected at anode and resulting current is then converted to voltage and measured. Application of the photomultiplier tube. The main application is detection of impurities. That means we detect the unwanted materials of the sample. Unwanted peak indicates. These are determined by using the photomultiplier detectors. And second one is to determine the purity. Whether the sample is impure or pure, that will be determined by using the photomultiplier detectors. And third one is to determine the quality of the drug substance. We use the sample, we use the drug material. The drug material is quality, whether the quality or not quality will be checked by using the photomultiplier tube. These are the applications of the photomultiplier detectors. After we change the electric signal, that will be read out by the systems or read out the measurement of in graphical representation. Next we see the standard plot on the readout value of the flame photometry. First we see the graph in the slide. In this graph, the concentration and the emission wavelength we plot. The graph will be denoted ABC. In A represents very low concentration range. In this emission fall below expected value due to ionization, as some atoms are converted to ions. For example, ionization of potassium. Potassium gives the potassium flux minus electron or loss. Such ionization is, however, significant at higher concentration. B denotes the linear region used for quantitative measurement. Third will represent high concentration, negative deviation. Photons emitted by the excited atoms are partly absorbed by ground state atoms in the flame. This is the graphical representation. Next we see the applications of flame photometry. First one, qualitative application. In this application we use the photometry for the determinations of alkali and alkaline earth materials, metals in samples. We are easily identified by using the flame photometry. Example, sodium produce yellow flame. It will be easily identified by the flame photometry. Non-radiating elements such as carbon, hydrogen, halides cannot be detected by the flame photometry. Second one, quantitative application. It helps to determine the suitability of the soil for cultivation. What soil we use for this wheat cultivation, that will be determined by using the flame photometry. Second one, determine of the concentration of the sodium potassium ion in body fluids. In our body fluids, we determine the concentration of sodium potassium level, since their ratio controls the action of muscles including the heart. Third one, analysis of water. Environmental, the main users application is environmental monitoring. The soil, water will be analyzed by using the flame photometry. Analyzing of water from various sources is carried out to determine its suitability for drinking, washing, agricultural and industrial purpose. We determine by using the flame photometry. Used for determinations of lead in petrol. Determine in petrol contain the lead, that will be identified by using the flame photometry. Fifth use, analyzing of soft drink, fruit juice and alcoholic beverages by using the flame photometry. Sixth one, the calibration curve is prepared by measuring the intensity of emission for the series of solution of different concentration, preparing by using the standard solution. The unknown sample can be determined by using the flame photometry. The other uses of flame photometry is determine the amount of metal present in the wastewater, that will be determined, and determine the hardness of the water, determine sodium, potassium, calcium, zinc present in cement, that will be determined by using the flame photometry. To determine the lead, already we see the uses, and to determine, used to check water quality by detecting the presence of metal ions, Unlike soft drinks, used, used to check water quality by detecting the presence of specific metal ion. To check the water purity, when the water where the water is pure or impure, that will be checked by the flame photometry. Unlike soft drinks, fruit juice, beverages, these are already seen in the application. Next one, to determine the elements in flame photometry, we use to used in the chemical research, and to analyze the soil quality will also determine the flame photometry. The concentration of the element is an unknown sample can then be found out from the standard plot as is done in visible spectrophotometry. These are the applications of the flame photometry. The flame photometry helps various reasons in the pharmaceuticals or others. These are the applications of the flame photometry. Next we see the merits and demerits. Merits, the main merits is the sensitivities and to determine the copper, iron and manganese elements will be determined. Next we determine the main merits is turbulence. It have this small area used for noiseless. Some flame photometers are noiseless, but some one is not noise. And the advantages, we see the advantages are it is simple, it is like inexpensive, no costless, high sample throughput method. Main is flame photometry. This flame photometry, the sample are high used, so this one is the advantage. For the clinical, this is used for the clinical, biological, environmental analysis. These are the advantages of the flame photometry. Now we revise the flame photometry. Today we see the flame photometry. In what flame photometry is also known as the flame emission photometry. Is a branch of spectroscopy that we are see. Flame microscopy is main used for the main helpful for the determination of elements, metals. They are emission spectroscopy. It is based on the emission spectroscopy main principle, and these atoms are excited to the ground state. The instrumentation we are see in instrumented sample delivery system, source, monochromator detectors, readout device. Sample delivery system we see that are nebulizer, aerosol modifier, flame or atomizer. These are C. Sources, the burners we use, structure of flame, zone, requirements and function we see. And as the list of fuels and oxidants used for the flame photometry, that also see. The Mechner burner and total consumption burner in burners are see how the work also see, and the laminar flow burners also see. Next we see the mirror. The mirror in flame photometry, mirror is used mirror purpose we also see. Mirror is placed behind the flame. Mirror helps to focus. Next we see monochromator. Monochromator's main use, the polychromatic light is converted into monochromatic light. There are two types, prism, gratin, that also see. Next is the detectors. Detectors we use light energy converted into the electrical signal and that are displayed on the readout device. That will we see. The types of device we see. First one, photo multiplot, two, photo emissive cell, photovoltaic cell. Photo multiplot, two, how do work, how the constructions are contained, that are see, and how the graph will be present in the flame photometry readout process device. That also see the ABC. A is very low concentration, B is linear region and used for the quantitative measurement, and C higher concentration and negative deviation. Photons emitted by the excited atoms are partially absorbed by ground state atoms in the flame. And last we see the applications of flame photometry. The main applications are determine the sodium, potassium, calcium, zinc present in cement, to determine the hardness of water, to determine lead present in petrol, used to check water quality by determining the presence of specific metal ions, analyzing soft drinks, fruit juice, beverages, to determine elements. It is used for the chemical research, analyze soil quality. These are seen in the flame photometry. And we see the qualitative application, quantitative application. In quantitative application, analyzing water and concentration of sodium, potassium and some body fluid we determine, and the determinations of lead in petrol. These also these are the quantitative application. And we see the merits of the flame photometry. The main merits is sensitivities, and it is inexpensive, it is simple, and high samples throughput methods for using the clinical, biological, environmental analysis. These are the seen in the flame photometry. Flame photometry is an emission spectroscopy. It is also known as flame emission spectroscopy. These are known about the flame photometry. Thank you.